Application Insights Unveiled, Mastering Performance, Reliability, and Observability in Modern Applications. Welcome to Observability, Why Application Insights Matters. 1.1 The Evolving Landscape of Modern Applications. In the early days of software development, applications often ran as single, large, self-contained units on a dedicated server. These monolithic applications were relatively straightforward to manage and monitor. If something went wrong, you typically knew where to look: the one big server running the one big application. Information about its health might be scattered across log files manually checked by an administrator or basic performance counters. Fast forward to today, and the software landscape has transformed dramatically. The rise of cloud computing, microservices, serverless functions, and containerization has shifted the paradigm. Applications are no longer isolated monoliths, but intricate constellations of interconnected services, constantly communicating with each other and with external systems. A simple user action, like logging into a website, might now trigger calls to several different services spread across multiple geographical regions, interacting with various databases, message queues, and external APIs. This distributed nature brings incredible benefits: scalability, resilience, independent deployments, and specialized teams. However, it also introduces a significant challenge: complexity. When a user reports that the website is slow, identifying the root cause is no longer a simple matter of checking one server. Was it the authentication service, the product catalog microservice, the database, an external payment gateway, a network glitch between regions, the front-end JavaScript? Each component might be running on a different server, perhaps even in a different cloud provider, all contributing a piece to the larger puzzle. Traditional monitoring tools and techniques, designed for simpler times, struggle to keep up. They might tell you if a server is up or down, or if a specific service is responding, but they often fall short in providing the holistic view needed to understand the intricate dance of a modern, distributed application. This is where the concept of observability steps in. 1.2 Introduction to Observability. Beyond traditional monitoring. To truly understand how a complex system behaves, we need more than just simple monitoring. Monitoring, in its traditional sense, is about watching for known conditions. It tells you what happened. For instance, a monitor might alert you if CPU usage exceeds 80% or if a server goes offline. These are known unknowns. Observability, on the other hand, is a deeper capability. It refers to how well you can infer the internal states of a system by examining its external outputs. Simply put, an observable system allows you to ask arbitrary questions about its behavior, not just the questions you thought to ask beforehand. It helps you understand why something happened, even for unknown unknowns. This is crucial for navigating the inherent complexity of modern cloud-native applications. Observability is often built upon three fundamental pillars. Logs. These are discrete, time-stamped records of events that occurred within your application. They describe specific occurrences, like a user logging in, an error being thrown, or a data transfer completing. Logs offer granular detail about individual actions. Metrics. These are numerical measurements collected over time. They represent aggregate data points about the system's performance and health, such as CPU utilization, request count per second, average response time, or the number of active users. Metrics are ideal for trending and alerting on system-wide health. Traces. These represent the end-to-end journey of a single request as it propagates through a distributed system. A trace connects all the individual operations performed by different services to fulfill that request, creating a complete story of its execution. Traces are critical for understanding latency, identifying bottlenecks, and debugging issues across multiple services. By combining and correlating data from these three pillars, you gain a comprehensive, holistic understanding of your application's behavior. This allows you to rapidly diagnose problems, understand performance characteristics, and gain insights into user interaction patterns, leading to a much more resilient and responsive application. This holistic approach empowers developers, operations teams, and even business stakeholders with the information they need to make informed decisions. For example, If users report slow website performance, metrics might show an increase in average response time. Drilling into logs might reveal a burst of errors from a specific service. A trace, however, would tie these together, showing that a particular user request originated from the web server, called a product service, which then called a slowly responding database, leading to the overall delay. This layered approach provides the full context. 1.3 Journey to Application Insights, from logs to intelligence. Historically, collecting and analyzing these vital pieces of information was a disjointed, manual effort. Developers would add print statements or write to log files. Operations teams would collect these files from various servers, often manually sifting through gigabytes of text, trying to piece together the sequence of events. Correlating errors in one service with performance degradation in another was a Herculean task, often performed under the immense pressure of an ongoing outage. This swivel chair monitoring approach, constantly rotating between different tools, dashboards, and log files, was inefficient, error-prone, and unsustainable for complex, dynamic cloud environments. The challenges included scattered data, log files on different servers, metrics in separate systems, and no easy way to link them. Lack of correlation. How do you know if an error in your payment service is related to a slow database query occurring at the same time in a different component? Scalability issues. Manual processing of logs doesn't scale with the volume of data generated by modern applications. Reactive posture. Identifying problems only after users reported them, leading to significant downtime and frustrated customers. Enter Application Insights. Microsoft recognized the acute need for a unified, intelligent solution to these problems within the Azure ecosystem. Application Insights was built to address these pain points directly, providing a comprehensive application performance, monitoring, APM service that integrates seamlessly with Azure and other environments. It streamlines the collection, storage, analysis, and visualization of the core observability, data logs, metrics, and traces, transforming raw data into actionable intelligence. It moves you from simply knowing something happened to understanding why it happened, who it affected, and what part of your intricate system was involved. This shift is analogous to moving from rudimentary gauges on a car dashboard to an advanced diagnostic system that not only shows speed and fuel, but can pinpoint a failing sensor, diagnose an engine issue, and even predict potential problems before they occur. 1.4 What is Azure Application Insights? Azure Application Insights is designed to monitor the health, performance, and usage of your live web applications. Whether your application is hosted in Azure, on-premises, or in another cloud environment, Application Insights provides deep insights into its behavior. It is a fundamental component of Azure Monitor, Microsoft's overarching observability solution for Azure resources. At its core, Application Insights functions by continuously collecting telemetry data from your running application. This data is then sent to your Application Insights resource within Azure, where it is meticulously processed, stored typically within an Azure Log Analytics workspace, and made available for analysis. The service's key capabilities and components include automatic telemetry collection. It automatically gathers metrics about requests, dependencies, calls to databases, external services, exceptions, performance counters, and more with minimal configuration. Custom telemetry. You can enrich the collected data by adding your own custom events, metrics, and dimensions, allowing you to track specific business processes, user actions, or internal application states unique to your application. Real-time insights. Features like Live Metrics Stream provide immediate, raw telemetry, allowing you to observe your application's pulse as it happens. Application Map. Automatically discovers the components of your distributed application and visualizes their interdependencies, showcasing health and performance at a glance. Powerful analytics. Using the Kusto Query Language, KQL, you can perform complex queries against your raw telemetry data, uncovering patterns, diagnosing issues, and answering detailed questions about your application's behavior. Performance diagnostics. Tools like flame graph visualizers and profiler help pinpoint performance bottlenecks down to the exact line of code. Availability monitoring. Web tests allow you to simulate user journeys, ensuring your application remains available and responsive from various global locations. Proactive alerting. Define rules to be notified automatically when critical performance issues, failures, or unusual patterns are detected. Integration with Azure ecosystem. Seamlessly works with other Azure services like Azure Dashboards, Azure DevOps, and Logic Apps for automated workflows. In essence, Application Insights transforms the opaque into the transparent. It gives you an X-ray view into your application, allowing you and your team to see precisely how it's performing, where bottlenecks might exist, who your users are, and how they are interacting with your software. 1.5. Why Application Insights is indispensable today. In today's fast-paced digital world, application performance directly impacts user satisfaction, business revenue, and brand reputation. A slow website or a buggy application can lead to lost customers and a damaged image. Application Insights helps you avoid these pitfalls and gain a competitive edge by making your applications more robust and reliable. Here are the key reasons why Application Insights is an indispensable tool for any modern team building and operating applications. Proactive problem detection. Instead of waiting for users to report issues, Application Insights helps you identify performance degradation, errors, or unusual behavior before they significantly impact your customers. This allows for rapid response and potentially preventing major outages. Faster root cause analysis. When problems do occur, Application Insights provides the detailed telemetry, correlated across services, to quickly pinpoint the exact cause. No more hours spent sifting through disconnected log files. The data is centralized and intelligently linked. Informed decision-making. Beyond just troubleshooting, Application Insights offers rich data on user behavior, feature adoption, and business-critical metrics. This intelligence empowers product managers, developers, and business analysts to make data-driven decisions about product development, resource allocation, and strategic direction. Optimizing resource utilization and cost. By identifying performance bottlenecks, inefficient code, or underutilized resources, Application Insights helps you optimize your application's performance and, consequently, its cloud infrastructure costs. Why pay for more computing power than you truly need if you can make your existing code more efficient? Enhanced DevOps and SRE practices. Application Insights slots perfectly into modern continuous integration, continuous delivery, CI/CD, pipelines, and site reliability engineering, SRE, philosophies. It provides the feedback loop necessary for automated release gates, validating deployments, and maintaining high levels of service reliability. This book will guide you through the intricacies of Azure Application Insights, starting from the very basics of setting it up, exploring its powerful telemetry collection capabilities, showing you how to extract meaningful insights from your data, and finally, demonstrating how to integrate it into your everyday development and operations workflows. By the end, you'll be equipped to leverage Application Insights to build, deploy, and operate applications that are not just functioning, but truly performant, reliable, and observable. Let's begin our journey into mastering your application's monitoring. 2. Getting started. Setting up your first Application Insights resource. You've learned why observability is crucial in today's complex application landscape, and how Azure Application Insights is uniquely positioned to provide it. Now, it's time to roll up your sleeves and get your first application connected. This chapter will walk you through the essential steps, from creating the Application Insights resource in Azure to configuring your application to send its precious telemetry data. 2.1. Choosing your deployment model. Before diving into the Azure portal, it's helpful to understand how Application Insights collects data from your application. There are essentially two main approaches, often referred to as deployment or instrumentation models. Automatic instrumentation, agent-based. How it works. This method uses pre-built monitoring agents or extensions that are injected into your application's environment. These agents automatically discover and collect standard telemetry, requests, dependencies, exceptions, performance counters, without requiring any changes to your application's code. Best for applications running on supported Azure services like Azure App Service, Azure Functions, Azure Spring Apps, or virtual machines with the appropriate monitoring agents installed. Benefits: quick and easy to enable, zero code changes, provides out-of-the-box performance monitoring. Limitations: less control over what data is collected, and you cannot send custom application-specific events or metrics without adding some code. Manual instrumentation, SDK-based. How it works. This involves adding Application Insights software development kits, SDKs, directly into your application's code. You then write specific lines of code to initialize the SDK and explicitly send telemetry data. Best for applications running anywhere on-premises servers, other cloud providers, desktop applications, mobile apps, or even if your Azure-hosted app requires custom telemetry beyond what the automatic instrumentation provides. Benefits: maximum control over what telemetry is sent, ability to send custom events, metrics, and dimensions tailored to your business logic, and fine-grained control over data volume. Limitations: requires code changes and deployment, which can be a barrier for existing applications. Many applications, especially those hosted on Azure, will benefit from a hybrid approach, using automatic instrumentation for foundational telemetry while also adding SDKs for specific business-critical custom events or advanced scenarios. Understanding these options will help you choose the most appropriate path for your monitoring needs. 2.2. Creating an Application Insights resource in Azure. The Application Insights resource in Azure is the central hub where your telemetry data will be sent, stored, and analyzed. Think of it as the brain of your monitoring setup. Here's a conceptual walkthrough of creating one in the Azure portal. Access the Azure portal, log in to your Azure account. Search for Application Insights. In the search bar at the top, type Application Insights and select the service from the results. Click Create. This will open the resource creation wizard. Basic details. Subscription. Choose the Azure subscription you want to use. Resource group. A resource group is a logical container for your Azure resources. You can select an existing one or create a new one. It's best practice to group related resources together, e.g., your application, database, and Application Insights resource could be in the same group. Name. Give your Application Insights resource a unique, descriptive name. Good naming conventions are important for clarity, especially as you add more resources, e.g., MyAppProd Insights, Web App Dev Insights. Region. Select the Azure region where your resource will be hosted. Ideally, this should be the same region or geographically close to the applications you are monitoring to minimize latency. Resource mode. This is a crucial setting. For modern applications, you should select Log Analytics Workspace-based. This choice means your Application Insights telemetry will be stored in a Log Analytics workspace. This offers several advantages. Unified data. All your Application Insights data, along with other monitoring data from Azure Monitor, can reside in a single Log Analytics workspace. Powerful queries. It leverages the full power of Kusto Query Language, KQL, allowing you to query Application Insights data alongside other logs. Cost optimization. Better cost management and data retention options via the Log Analytics workspace. Log Analytics workspace. If you selected Log Analytics Workspace-based, you'll either choose an existing Log Analytics workspace in the same subscription and region or create a new one. If you're starting fresh, creating a new workspace is simplest. Review plus create. After configuring the basic settings, Azure will perform a final validation. Review your choices and then click Create. The deployment process typically takes a few moments. Once complete, you will have a shiny new Application Insights resource, ready to receive telemetry from your applications. 2.3. Connecting your application to Application Insights. With your Application Insights resource created, the next step is to configure your application to send data to it. The key piece of information that links your application to your Application Insights resource is the connection string. The connection string contains the instrumentation key, an older identifier still used in some contexts, and other necessary endpoints that tell your application where to send its telemetry. You can find your connection string by navigating to your Application Insights resource in the Azure portal and looking for the Essentials section or Overview Blade. Let's explore how to configure your application based on the deployment model. Configuring for Azure App Service Functions, automatic instrumentation. For applications hosted on Azure App Service or Azure Functions, enabling application insights is often as simple as a few clicks in the Azure portal. Navigate to your app service or function app. In the Azure portal, find the specific app service or function app you want to monitor. Access Application Insights settings. In the left-hand menu of your app service or function app, look for Application Insights under the Settings section. Enable Application Insights. If it's not already enabled, you'll see an option to turn on Application Insights. Click this. Select your resource. The portal will prompt you to select an existing Application Insights resource or create a new one. Choose the resource you created in the previous step. Apply settings. After selecting your resource, the App Service Function app will configure itself, typically by adding an applicatio, an sightsco, an nectio, an string environment variable to your application's configuration. Once enabled, the Azure monitoring agent built into these services will automatically start collecting performance data, requests, dependencies, and exceptions from your application. You won't need to change any code in your application unless you want to send custom telemetry. Configuring for Net, Java, Node.js, Python, SDK-based. If you're using SDK-based instrumentation, for applications not on supported Azure platforms, or for adding custom telemetry, the process involves including the Application Insights SDK in your project, and then configuring it. While we won't show specific code blocks, the conceptual steps are as follows. Add the Application Insights SDK. For languages like Net, Java, Node.js, or Python, this means adding the relevant Application Insights SDK library or package to your project. This is typically done using package managers, e.g., NuGet for Net, Maven/Gradle for Java, npm for Node.js, pip for Python. Initialize the SDK. In your application's startup code, e.g., the main method, application startup class, or web server entry point, you will programmatically initialize the Application Insights SDK. This initialization process is where you typically pass your Application Insights connection string. Conceptually, you're telling the SDK, hey, I'm ready to send telemetry, and here's where you should send it. Automatically collected telemetry. Once initialized, the SDK for server-side applications will often automatically begin collecting core telemetry like incoming requests, outgoing dependencies, and unhandled exceptions without further code. Client-side, JavaScript applications. For web applications running in a browser, you use the Application Insights JavaScript SDK. This typically involves placing a small script snippet in your web page's HTML, which then collects page views, browser timings, and user interactions. The key across all these SDK-based approaches is providing that connection string during initialization. This is the handoff that allows your application to talk to your Application Insights resource. 2.4. Sending your first telemetry data. Once your application is configured, either through automatic instrumentation or SDK setup, it should almost immediately start sending telemetry. The quickest way to verify data flow is by checking the Live Metrics stream. Navigate to Live Metrics stream. In the Azure portal, go to your Application Insights resource and look for Live Metrics stream under the Monitoring section. Observe the stream. As soon as your application processes requests or performs actions, you should see data flowing in real time. You'll observe metrics like requests, incoming calls to your application, dependencies, any calls your application makes to other services, databases, external APIs, process CPU, your application's CPU usage, process memory, memory consumption, collected telemetry, small samples of individual request, dependency, and exception items, giving you a glimpse into the raw data. Generate traffic. To see data, you need to generate some activity in your application. Browse its pages, click some buttons, or interact with an API endpoint. Seeing data in the Live Metrics stream is confirmation that your Application Insights setup is working and that your application is actively sending telemetry. This immediate feedback loop is incredibly satisfying and provides confidence in your monitoring configuration. You can also navigate to other sections within your Application Insights resource, such as the Performance blade to see aggregated request and dependency performance, or the Application Map to see automatically discovered components, to further confirm that data is being processed and visualized beyond the real-time stream. 2.5. Structuring your Application Insights strategy. As you begin to monitor more applications or multiple environments, development, testing, production, you'll need a strategy for organizing your Application Insights resources. One resource per application environment. A common and recommended pattern is to have a separate Application Insights resource for each unique application and each environment. Example: MyApp Production App Insights, MyApp Staging App Insights, MyApp Development App Insights. Benefits: clearly separates data, prevents test data from polluting production metrics, allows independent alerting and configuration. Consideration: this leads to more resources to manage, but the clarity and isolation are usually worth it. Centralized Log Analytics Workspace. While you have separate App Insights resources, all of them can share the same underlying Log Analytics workspace, especially if they are related applications within the same team or business unit. This consolidates all your application-level telemetry and other Azure monitoring data into a single location for powerful cross-resource Kusto Query Language (KQL) querying. Naming conventions. Implement clear and consistent naming conventions for your resources, e.g., Application Name Environment App Insights, and resource groups. This makes it easier to navigate the Azure portal and understand the purpose of each resource at a glance. Establishing a clear strategy early on will prevent complexity and confusion down the line as your monitoring needs grow. Key takeaways. Setting up Application Insights is your first and most critical step towards achieving comprehensive observability for your applications. By understanding the distinction between automatic and SDK-based instrumentation, correctly creating your Application Insights resource, and ensuring your application is sending data through the connection string, you lay the foundation for collecting rich telemetry. Confirming data flow in the live metrics stream provides immediate validation, and an organized strategy for managing multiple resources ensures scalability and clarity as your monitoring landscape evolves. You're now ready to delve into the fascinating world of telemetry data itself. 3. The heart of monitoring, understanding telemetry data. You've successfully set up your Application Insights resource and connected your application. You're seeing the glorious flow of data in the live metrics stream, a tangible sign that your application is talking. But what exactly is it saying? This chapter delves into the fundamental types of telemetry data collected by Application Insights. Understanding these building blocks is crucial, as they form the bedrock of all the insights you'll derive about your application's health, performance, and usage. 3.1 Introduction to Telemetry. The language of your application. Telemetry can be thought of as the language your application uses to communicate its internal state. It's the structured data detailing every significant operation, interaction, and event happening within your software. Instead of relying on guesswork or anecdotal reports, telemetry provides concrete, measurable facts. Every piece of telemetry, irrespective of its type, is essentially a record of a specific aspect of your application's behavior. This continuous stream of information, when collected, stored, and analyzed, enables data-driven decisions that are superior to intuition alone, especially as applications become more complex and distributed. It helps answer questions like, is the application performing as expected? Are users encountering errors? What external services is the application relying on, and how are they performing? Which features are most popular and which are underutilized? Where are the performance bottlenecks? Each telemetry item contains specific properties that provide context. For example, a request telemetry item would include the URL, the response time, and whether it succeeded or failed. This context is what makes the raw data actionable. 3.2 Core Telemetry Types. Application Insights automatically collects several fundamental types of telemetry, each providing a different lens through which to view your application's operations. Let's explore these core types. Request. What it is, represents an incoming request to your application. For web applications, this is typically an HTTP request from a user's browser or another service. What it tells you. A request telemetry item records details about each web request received by your application, including the URL path e.g. /API/products/123, the duration it took your application to process the request, the HTTP response code, e.g. 200 OK, 404 not found, 500 internal server error, whether the request was successful or failed. Why it matters. Request telemetry is fundamental for understanding your application's overall performance and reliability from an external perspective. It helps you monitor response times, identify popular endpoints, and track the number of failed requests. A sudden increase in failed requests or a spike in average duration for a critical endpoint can signal a problem that needs immediate attention. Dependencies. What it is, represents an outgoing call from your application to another service or resource. This could be a call to a database, an external API, a message queue, a blob storage service, or even another microservice within your own ecosystem. What it tells you, a dependency telemetry item captures information about these external interactions. The type of dependency, e.g., SQL database, HTTP call, Azure blob storage. The target name, e.g., your database server name, the external API endpoint. The duration of the call, whether the call was successful or failed. The specific command or operation performed, e.g., a SQL query statement. Why it matters. Dependencies are crucial for diagnosing bottlenecks and understanding the health of your application's external connections. If your application is slow, it might not be your code's fault. A slow database query or an unresponsive third-party API could be the culprit. Dependency telemetry helps you pinpoint exactly which external components are causing delays or errors. Exceptions. What it is, represents an error or abnormal condition that occurred within your application's code. This includes unhandled exceptions that might crash your application or specific exceptions that you choose to track manually. What it tells you. Exception telemetry provides vital debugging information. The exception type, e.g., null reference exception, HTTP request exception. The exception message. The call stack, the sequence of methods that led to the exception, showing the exact line of code where the error originated. Severity level. Why it matters. Exceptions are a direct indicator of code defects or unexpected situations. Tracking them allows you to identify bugs, understand which parts of your application are fragile, and prioritize fixes based on the frequency and impact of specific errors. Catching these early can prevent a minor glitch from becoming a major customer frustration. Page views, client-side. What it is, generated predominantly by client-side JavaScript SDKs. A page view represents when a user navigates to and loads a page in their web browser. What it tells you, the URL of the page loaded. The duration it took for the page to load in the browser, details about the user's browser, operating system, and geographic location. Why it matters. Page view telemetry is essential for understanding user engagement and front-end performance. It provides insights into which pages are most popular, how long users spend on them, and if specific pages are loading slowly in the user's browser, which might be due to large images, slow scripts, or network latency rather than server-side issues. Browser timings, client-side. What it is, a more granular breakdown of the page view detailing the stages of a web page loading in the user's browser. What it tells you, specific timings for network latency, how long it took to download resources, processing time, how long the browser took to parse the HTML and execute scripts, rendering time, how long it took to paint the page on the screen. Why it matters. This telemetry allows front-end developers to fine-tune the user experience. You can identify if slow performance is due to large assets, inefficient JavaScript, or excessive server network latency impacting the user directly, while not explicitly listed as a core telemetry type. In the same way as requests or exceptions, it's vital to remember that Application Insights also collects performance counters. These are low-level system metrics like CPU utilization, memory usage, disk I/O, and network I/O They provide insight into the underlying infrastructure health and capacity, and are displayed alongside your application-specific telemetry. 3.3 Data Structure and Properties. Every single telemetry item collected by Application Insights isn't just a simple value. It's a rich object packed with crucial contextual metadata. This metadata, known as properties, is what transforms raw data into meaningful insights. Think of it like this. A request telemetry item doesn't just say, "A request happened." It says, "A request to products new happened, it took 250 milliseconds, it returned a 200 OK status, and it was handled by web server 01 in the production environment." Each of those additional pieces of information is a property. Common properties automatically associated with telemetry include timestamp, when the event occurred; operation ID, a unique identifier that links all telemetry items for a single end-to-end operation across different services. This is critical for distributed tracing. Application name role instance identifies the specific application and instance that generated the telemetry. Client information, IP address, geographic location, user agent browser OS. User information, if configured and available, anonymous user IDs, session IDs. The intelligent correlation of individual telemetry items through properties like the operation ID is what enables Application Insights to stitch together a narrative of complex interactions, visualize them in the application map, and allow you to trace the full journey of a user's request, even if it spans multiple microservices. You also have the power to add your own custom properties to any telemetry item. For example, when tracking a payment processed event, you might add custom properties like customer ID, order value, and payment gateway used. This allows you to slice and dice your data based on your specific business needs, going far beyond default technical metrics. 3.4 The role of Log Analytics Workspace. As mentioned in the previous chapter, for modern Application Insights resources, all the telemetry data is stored within an Azure Log Analytics Workspace. Think of the Log Analytics Workspace as a powerful database specifically designed for storing and querying vast volumes of log and telemetry data. Within this workspace, Application Insights telemetry is organized into different tables, each corresponding to a primary telemetry type. For instance, you will find tables named Requests stores all your incoming request telemetry. Dependencies contains all your outgoing dependency calls. Exceptions holds all captured exception details. Page views for client-side page load data. Browser timings for detailed browser performance metrics. Traces for log messages, often referred to as traces in App Insights context. Custom events for event data you've explicitly tracked. Custom metrics for numerical metrics you've explicitly tracked. Performance counters for system-level performance metrics like CPU, memory. Availability results for web test results. Each table has a predefined schema, a set of columns that makes the data highly structured and efficiently queryable. For example, the requests table will have columns like URL, duration MIS, success, result code, item ID, timestamp, and many more properties. This structured storage within Log Analytics is incredibly powerful because it unlocks the full capabilities of the Kusto Query Language, KQL. While we'll dive deep into KQL in a later chapter, it's important to understand now that KQL is your primary tool for extracting precise insights from this sea of data. You won't be manually parsing log files. You'll be writing powerful queries to find exactly what you need. 3.5 Viewing telemetry in the Azure portal. The Azure portal provides several pre-built visualizations and blades to help you explore your telemetry, even before you start writing custom KQL queries. Logs blade. This is your direct access point to the raw data stored in Log Analytics. When you open this blade from your Application Insights resource, you'll see a query editor where you can start writing KQL queries against the requests, dependencies, exceptions, and other tables. It's often the first place you go for detailed investigation. Performance blade presents aggregated performance data for your requests and dependencies. You can see top slow requests, filter by operation name, and examine trends over time. This offers a high-level overview of where your application might be experiencing performance issues. Failures Blade provides a clear overview of failed requests and exceptions. It groups similar failures, allowing you to prioritize the most frequent or impactful issues. You can then drill down into individual failure instances to see the full context, including associated requests, dependencies, and stack traces. These portal views are invaluable for a quick understanding of your application's health. But the real power comes from combining your understanding of these telemetry types with the flexible querying capabilities of KQL. Key takeaways. Telemetry is the lifeblood of application insights. By understanding the core types of data it collects, requests, dependencies, exceptions, page views, and browser timings, you gain foundational knowledge about how your application is performing and behaving. Recognizing that all this rich, contextual data is structured into tables within a log analytics workspace sets the stage for advanced querying with Kusto Query Language, allowing you to transform this data into actionable intelligence. Knowing what your application is trying to tell you is the critical first step towards mastering observability. 4. Real-time insights, live metrics and application map. You've learned about the different types of telemetry data that Application Insights collects. But what if you need to see what's happening right now? What if you've just deployed a new version of your application and need immediate confirmation that everything is stable? Or perhaps you need to quickly grasp the architecture of a complex microservices application. This chapter introduces two powerful visualization tools within Application Insights that provide instant, real-time insights. Live Metrics Stream and Application Map. 4.1 The need for real-time monitoring. In the fast-paced world of modern application development and operation, immediate feedback is invaluable. Waiting minutes or hours for dashboards to refresh or for data to propagate through analytics pipelines can be detrimental, especially during critical moments like post-deployment validation. After deploying a new version of your application, you want immediate assurance that it's healthy, not generating new errors, and performing as expected. Active incident response. During an ongoing outage or performance degradation, every second counts. You need to see the current state of your system to quickly diagnose and contain the problem. Traffic spike management. When your application experiences sudden surges in user activity, e.g., a flash sale, a popular news event, you need to monitor resource utilization and performance in real time to ensure stability and plan for scaling. Debugging in production with care. Sometimes, a bug only manifests under specific real-world production conditions. Real-time insights allow you to observe your application as it handles actual user traffic, helping you identify elusive issues. Traditional monitoring often involves looking at historical data or dashboards with some data latency. While this is great for trending and long-term analysis, it's insufficient for these immediate needs. Live Metrics Stream and Application Map fill this gap, offering dynamic, current views of your application's heart and intricate web of dependencies. 4.2 Live Metrics Stream. The pulse of your application. The Live Metrics Stream is arguably one of the most compelling features of Application Insights for anyone involved in development and operations. It provides a real-time, low-latency stream of core metrics and sample telemetry directly from your application's process. Think of it as an echocardiogram of your application, showing its immediate vitals. When you open the Live Metrics Stream from your Application Insights resource in the Azure portal, you'll see a dynamic dashboard that typically includes request rate and duration, how many requests your application is handling per second and their average processing time, failed requests, the rate at which requests are failing. A sudden spike here is a critical indicator. Dependency calls, the rate and duration of calls your application is making to external services. Exceptions, the rate of exceptions occurring within your application. Process CPU and memory, the current CPU utilization and memory consumption of your application's host process. Custom metrics, if you're sending any custom numerical metrics, which we'll discuss in a later chapter, they will also appear here. Beyond these aggregated metrics, the Live Metrics Stream also displays sample telemetry. This is incredibly useful because it shows actual, individual requests, dependency calls, and exceptions as they happen. You can see the URLs of incoming requests, the names of the databases being called, and the error messages of exceptions, all in real time. This provides immediate, granular context for what's happening. Use cases for live metrics stream, post-deployment sanity checks, deploy a new version, and immediately open live metrics. A healthy stream confirms your deployment was successful. Any sudden increases in errors, CPU, or memory usage signal a problem. Immediate troubleshooting. If users report a problem, opening live metrics can help you quickly ascertain if it's a systemic issue, e.g., a flood of errors or an isolated incident. You might even see the specific request or error that's causing the problem. Observing performance under load. During a load test or a period of high legitimate traffic, live metrics allows you to watch your system react, confirming scaling policies or identifying bottlenecks as they manifest. Validating custom telemetry. If you're sending new custom events or metrics, e.g., tracking a user registration, live metrics is an excellent way to confirm they are indeed flowing into application insights as expected. The live metrics stream operates by maintaining a real-time connection from your application's SDK to application insights within Azure. This continuous, low-latency communication makes it perfect for those moments when every second of visibility counts. 4.3 Application Map, visualizing your system's flow. While live metrics gives you an immediate pulse of individual components, the application map provides a visually compelling overview of your entire application's architecture and its health. It automatically discovers the components of your distributed system and maps their interactions, highlighting performance and reliability issues. Imagine application map as a living blueprint of your microservices ecosystem. It shows nodes. Each rectangle on the map represents a component of your application, whether it's a web app, an API, a database, an external service, or even another Azure resource. Edges, connections. The lines connecting the nodes represent communication flows between components. These show dependencies. For instance, your web application communicating with a payment gateway. Health and performance indicators. The nodes and edges are color-coded and display metrics directly on the map. You'll instantly see response times, average duration of calls, error rates or number of failed calls, traffic volume, requests per second. Visual cues for health. Green usually means healthy, yellow indicates a potential issue, e.g., slow performance, and red signifies critical problems, e.g., high error rates. Core elements of application maps power. Auto-discovery. Application Insights is clever enough to figure out how your components are interacting, even if you haven't explicitly configured these relationships. It achieves this by linking telemetry items across different services using correlation IDs. Distributed tracing, high level. Application Map leverages the concept of distributed tracing to stitch together calls across services. For example, if a web request hits your front end, which then calls an authentication microservice, which in turn queries a database, the map shows this entire chain. This is invaluable when diagnosing performance issues that span multiple services. Drill down capabilities. You can click on any node or edge on the map to get more detailed information about that specific component or interaction. From there, you can navigate directly to the performance, failures, or logs details for that part of your system. This allows for quick contextual movement from a high-level overview to granular diagnostic data. Use cases for application map. Understanding complex architectures. For new team members or when troubleshooting an unfamiliar system, application map provides an instant visual understanding of how everything fits together. Identifying bottlenecks at a macro level. If one node or connection on the map is showing high latency or a high error rate, you immediately know where to focus your investigation. Verifying connectivity. After network changes or deployments, the map can quickly confirm that all expected connections between components are active and healthy. Validating design intent. Does the actual communication flow match what you designed? Application Map reveals the true runtime topology. 4.4 Comparing live metrics and application map. While both live metrics stream and application map deliver powerful real-time insights, they serve slightly different purposes. Live Metrics Stream focuses on the immediate, raw telemetry and key performance indicators of individual application instances. It's about seeing the vitals and samples of data flowing now. Perfect for a quick check after a deployment or when debugging a live, unfolding incident at a granular level. Application Map provides a system-wide visual topology of your application and its dependencies. It's about understanding the relationships and health of multiple components and their interactions. Ideal for understanding architecture, identifying problematic services, and seeing how a request traverses your entire distributed system. Together, these two features complement each other, offering both the granular detail of an application's current operations and the high-level perspective of its overall health and architecture. They are your eyes and ears for staying on top of your application's dynamic behavior in real time. Key takeaways. Real-time visibility into your application's behavior is critical for rapid detection, diagnosis, and validation. Live Metrics Stream offers an immediate, granular view of your application's heartbeat, displaying key metrics and sample telemetry as they occur. Application Map, on the other hand, provides a powerful visual representation of your entire application's architecture, automatically discovering its components and their dependencies, highlighting areas of concern. Mastering these two tools provides an unparalleled ability to understand and react to the dynamics of your modern applications. 5. Ensuring availability. Web tests and proactive monitoring. In the digital age, application availability isn't just a technical metric. It's a critical component of customer satisfaction and business success. An application that is unavailable or unresponsive might as well not exist. Users quickly abandon sites that don't load, transactions that fail, or services that constantly time out. This chapter explores how Application Insights helps you proactively monitor the availability of your web applications and services, ensuring they are always up and running, ready to serve your users. 5.1. Understanding application availability. When we talk about availability, it's more than just the server being powered on. For an end user, available means they can successfully complete their intended task. This includes reachability. Is the application accessible from various geographical locations and internet service providers? Responsiveness. Is it loading within an acceptable timeframe? Functionality. Can users log in, browse products, submit forms, or complete a purchase successfully? A simple ping test might tell you if your server is reachable, but it doesn't confirm if your application logic is working correctly or if a critical part of your user journey is broken. Application Insights provides sophisticated tools to go beyond basic endpoint monitoring, simulating real user experiences to give you a comprehensive view of availability. 5.2. URL ping tests. Basic uptime monitoring. The simplest form of availability monitoring in Application Insights is the URL ping test. This test performs a basic HTTP GET request to a specified URL from various global locations at regular intervals. Purpose: to quickly determine if a public endpoint of your web application or API is accessible and returning a healthy response, e.g., HTTP 200 OK. Configuration: URL. The full URL you want to test, e.g., https www.yourdomain.com or https api.yourdomain.com/health. Test frequency. How often the test should run, e.g., every 5 minutes. Test locations. From which geographical locations the test should originate, e.g., US West, Europe North, Asia East. Running tests from multiple locations helps identify regional connectivity issues. Success criteria. You can define what constitutes a successful response, such as a specific HTTP status code, e.g., 200, or the presence of specific text content on the page to ensure dynamic content is loading. Alerting. You can configure alerts to trigger if the test fails for a certain number of locations or consistently over a period. This ensures you're notified immediately if your application becomes unreachable. Limitations. While useful for basic uptime checks, URL ping tests only verify that the specified URL responds. They don't test the deeper business logic of your application or simulate complex user flows that might uncover issues in downstream services. For that, we need something more powerful. 5.3 Multi-step web tests, simulating user journeys. Multi-step web tests are a significantly more robust way to monitor availability. Instead of just pinging a single URL, they simulate an entire sequence of user actions, effectively walking through a critical business process of your application. Purpose: to verify that complex user journeys are functioning correctly from end to end. This can uncover issues with login processes, search functionality, shopping cart flows, or multi-page forms that a simple URL ping test would miss. How it works conceptually. Recording. You typically record a sequence of web requests and responses using a web testing tool, historically Visual Studio Web Performance tests, though the industry is moving towards other standard formats. This recording captures all the HTTP requests, form submissions, and authentication steps that a user would perform. Assertions. Within the recorded sequence, you add assertions. These are checks to ensure the application behaves as expected at each step. For example, after a login step, you might assert that "Welcome username" appears on the next page or that a specific button is present. After submitting an order, you might assert that an order confirmation message is displayed. Playback and monitoring. Application Insights uses this recorded sequence to regularly play back the steps from various global locations, just like ping tests. If any step fails, e.g., a page doesn't load, an assertion isn't met, or an unexpected error occurs, the test is marked as failed. Benefits: true end-user experience monitoring, simulates what your users actually do. Early detection of broken workflows, uncovers issues in business logic, authentication flows, or integrations with external systems. Comprehensive failure details. When a multi-step test fails, Application Insights captures details for each step, including HTTP status codes and response content, helping you diagnose the exact point of failure. Use case. Imagine an e-commerce application. A URL ping test might confirm the home page is up. A multi-step web test, however, could simulate visiting the home page, searching for a product, adding the product to the cart, proceeding to checkout, attempting to log in, navigating to the payment page. If any of these steps fail, you're alerted, knowing that a critical part of your customer's journey is broken. 5.4 Custom Availability Reporting. While URL ping and multi-step tests are excellent for external-facing web applications, sometimes you need to monitor the availability of internal services, background processes, or other non-web components. In such cases, Application Insights allows you to programmatically send custom availability results. Purpose: to report the health of components that aren't directly exposed via public URL or processes that involve unique success criteria. How it works conceptual. You integrate the Application Insights SDK into your background service or worker process. Within your code, you execute a check or task, e.g., query a database, process a message from a queue, call an internal API, and then explicitly report the outcome using the track availability method or similar in the relevant SDK. Information sent: you specify a test name, duration, and whether the test was successful. You can also include a failure message or error details. Benefits: extends availability monitoring beyond standard web interfaces to cover the entire spectrum of your application's architecture. For example, a background job that cleans up old data might report its success or failure using custom availability. Or an internal microservice could regularly check its connection to a critical internal dependency and report its own health status to Application Insights. 5.5 Proactive alerting on availability deviations. The real value of availability monitoring comes from being notified immediately when something goes wrong. Application Insights integrates seamlessly with Azure Monitor alerts, allowing you to set up rules that trigger actions based on the results of your web tests. Alert conditions. You can define alerts based on test failures. If a web test fails for a certain number of locations or within a given time window. Response time thresholds. If the average response time of a web test exceeds a specified duration. Specific metrics. For example, if the percentage of successful web test runs drops below a certain threshold, e.g. 90%. Action groups. These define who gets notified and how. An action group can include various notification types. Email, send an email to an individual or a distribution list. SMS, send a text message to a mobile number. Push notification, send a notification to the Azure mobile app. Webhook, call a custom endpoint, allowing integration with incident management systems, e.g., PagerDuty, ServiceNow, collaboration tools, e.g., Slack, Microsoft Teams, or custom automation tools. Voice call, initiate an automated phone call. ITSM tool, create a work item in an IT service management solution. Runbooks/Logic app, trigger an automated remediation script or workflow. By configuring robust alerts and action groups, you ensure that the right people are informed in the right way, allowing for swift investigation and resolution of availability issues before they escalate. 5.6. Designing for high availability and monitoring considerations. While Application Insights helps you monitor availability, it's crucial to remember that robust monitoring is only one piece of the puzzle. True high availability comes from architectural design choices, such as redundancy, having multiple instances of your application and its dependencies. Failover mechanisms, ensuring that if one instance fails, traffic automatically reroutes to a healthy one. Disaster recovery, planning for how your application recovers from major regional outages. Load balancing, distributing traffic evenly across healthy instances. Application Insights helps you validate these architectural patterns. By running web tests from different regions, you can confirm that your global load balancing is working correctly. By observing response times and failures during a simulated failover, you can verify your recovery mechanisms. It transforms theoretical design into confirmed operational reality. Key takeaways. Application availability is non-negotiable for modern applications. Application Insights provides powerful tools to move beyond simple, "Is it up?" checks to genuine end-to-end user experience monitoring. URL ping tests offer foundational uptime checks, while multi-step web tests simulate critical user journeys, proactively identifying issues within complex workflows. The ability to send custom availability results extends monitoring to internal services, and seamless integration with Azure Monitor alerts ensures immediate notification through flexible action groups. By leveraging these capabilities, you gain confidence that your application is not just running, but truly available and functional for your users around the clock. 6. Performance Deep Dive. Metrics, performance counters, and dependencies. In the previous chapter, we explored how Application Insights helps you ensure your application is available. But an application can be available and technically functioning, yet still deliver a poor user experience if it's slow. Performance is paramount, directly impacting user satisfaction, conversion rates, and even search engine rankings. This chapter dives deep into how Application Insights provides granular insights into your application's performance, from high-level summaries to code-level bottlenecks. 6.1. The Performance Spectrum. From global to granular. Understanding performance isn't a one-size-fits-all endeavor. It requires looking at data from various perspectives. Overall application performance. How fast is your application responding on average to all user requests? Specific endpoint performance. Are certain pages or APIs significantly slower than others? Component-level performance. Is a particular microservice or database connection causing delays? Code-level performance. Is a specific function or line of code consuming excessive resources or taking too long to execute? Application Insights gives you the tools to analyze performance across this entire spectrum, helping you pinpoint where to focus your optimization efforts for maximum impact. 6.2. Built-in performance metrics. Application Insights automatically collects several key performance metrics, forming the foundation of your performance analysis. Request performance. Average response time. The average duration it takes your application to process incoming requests. Request count. The number of requests your application handles per unit of time. Success rate. the percentage of requests that returned a successful HTTP status code, typically 200 OK. These metrics are crucial for understanding the overall health and responsiveness of your web application or API. A sudden increase in average response time or a drop in success rate immediately signals problems. Dependency performance. Average dependency duration. The average time your application spends waiting for responses from external services, databases, APIs, message queues. Dependency call count. The number of calls your application makes to these external services. Dependency success rate. The percentage of successful calls to external services. These are vital for identifying bottlenecks outside your application's direct control. A slow database or a third-party API outage will often manifest as poor dependency performance. Browser performance, client-side. Page view load time, the overall time it takes for a user's browser to fully load a page. Browser timings, a detailed breakdown of the page loading process, e.g., DNS resolution, connection time, send-receive time, DOM processing, rendering. These metrics are collected by the client-side JavaScript SDK and provide direct insight into the user's perceived performance, often revealing front-end specific issues that server-side metrics might miss. You can observe these metrics in the Performance blade of your application Insights resource in the Azure portal, which provides interactive charts and tables to help you slice and dice the data, compare different operations, and identify trends. 6.3 Performance counters, low-level system insights. While the metrics above tell you about your application's behavior, performance counters give you insights into the underlying infrastructure it's running on. These are low-level system-wide measurements that reveal how much strain your application is putting on the server or virtual machine resources. Application Insights agents automatically collect common performance counters, such as CPU utilization, the percentage of processor time being used. High CPU usage can indicate inefficient code or insufficient computing power. Memory usage, how much RAM your application process is consuming. Memory leaks or excessive object creation can lead to high memory usage, impacting performance. Disk I/O, the rate at which your application is reading from and writing to disk. Slow disk operations can be a major bottleneck if your application is disk-bound. Network I/O, the amount of data being sent and received over the network. Network bottlenecks can impact communication with other services. Value, by correlating these system-level metrics with your application's performance data, you can diagnose if performance issues are due to inefficient code, high CPU memory usage for simple tasks, or simply insufficient resources, hitting limits even with efficient code. For instance, if your request times are spiking and you simultaneously see a sustained 100% CPU utilization, it suggests your instance is overwhelmed and might need to scale up. 6.4 Decoding dependency performance. Dependencies are often the hidden culprits behind application slowdowns. Your application might be perfectly optimized, but if it has to wait for a slow third-party API or an overloaded database, the end-user experience will suffer. Application Insights provides detailed dependency tracking to help you identify these external bottlenecks. In the Performance blade, besides overall request performance, you'll find dedicated sections for analyzing dependencies. Here you can see Top Slow Dependencies, a list of the external services or databases that have the highest average response times. Dependency types, breakdown by type, e.g., SQL, HTTP, Azure Blob. Specific operations. For SQL dependencies, you might even see the specific queries being executed and their performance. When investigating a request that suddenly became slow, you can drill down into the end-to-end transaction details, which we will cover more in depth in a later chapter on distributed tracing. Here, you'll see a waterfall chart or hierarchical view showing every dependency call made during that request, along with its duration. This allows you to visually identify the specific calls that are taking the longest. Use case. Imagine a scenario where a product details page in your e-commerce application becomes very slow. Application Insights allows you to quickly see that while your application code execution is fast, the dependency call to the database to fetch product information is taking hundreds of milliseconds. Drilling further, you might even identify the exact SQL query responsible for the delay, pointing to a need for query optimization or indexing. 6.5 Application Profiler. Uncovering code-level hotspots. Sometimes the performance problem isn't an external dependency or an overwhelmed server. It's a specific piece of code within your application that is running inefficiently. This is where Application Profiler comes in. Purpose. Application Profiler is a service that automatically collects performance traces from your live application, providing incredibly detailed insights into the execution paths of your code. It shows you exactly which lines of code are contributing most to the CPU time, waiting time, or blocking operations during a request. How it works: conceptual. When enabled, the profiler periodically takes snapshots of your application's call stack and CPU usage in production. It intelligently identifies hot paths, code segments that are consuming a disproportionate amount of time, especially when an application insights request is taking longer than expected. It then correlates these code-level traces with the telemetry from that request. Value. This is often referred to as drill down to the method level. It helps answer questions like, why is this specific API call taking 500 ms, even though there are no slow dependencies? Is a certain loop or algorithm in my code computationally expensive? Am I accidentally performing a blocking operation, like waiting for a lock, that's slowing things down? Integration. Application Profiler works for Net and NetCore applications deployed to various Azure services like App Service, Azure Functions, VMS, and virtual machine scale sets. Example outcome. Instead of just seeing request/API/products took 500 ms, Profiler might show you that 400 ms of that time was spent inside a process complex calculation method within your code, giving you a precise target for optimization. 6.6 Metrics Explorer. Custom views of performance data. While the performance blades offer predefined views, the Metrics Explorer in Application Insights, part of Azure Monitor, is your canvas for creating custom charts and analyzing arbitrary performance data. Purpose: to build your own interactive performance dashboards and conduct ad hoc analyses using various metrics collected by Application Insights. How to use. Select your Application Insights resource. Choose a metric namespace, e.g., Application Insights Standard Metrics. Select a metric, e.g., server response time, request rate, CPU usage. Choose an aggregation, e.g., average, sum, max. Split by. You can break down the metric by various dimensions, e.g., instance name, operation name, client city, to see how performance differs across different segments. Add filter. Apply filters to focus on specific data, e.g., only requests to a particular URL. This powerful tool allows you to combine different metrics, visualize trends, and create highly customized views tailored to your specific performance monitoring needs, empowering you to identify subtle patterns or correlations that might otherwise be missed. Key takeaways. Application Insights provides a comprehensive toolkit for deep performance analysis. From high-level metrics on requests and dependencies to low-level performance counters and code-level profiling, you have the data to identify and resolve bottlenecks at every layer of your application stack. Understanding how to leverage these various data points, both the automatically collected and the custom views you create in Metrics Explorer, is crucial for continuously optimizing your application's responsiveness and overall user experience. 7. Hunting for anomalies, failures, exceptions, and profiling. Even the most meticulously designed and robust applications will encounter failures. It's an inevitable truth of software development. Whether it's an unexpected input from a user, a temporary network glitch, a configuration error, or an elusive bug that only manifests under specific conditions, applications will break. The mark of a reliable system isn't that it never fails, but that it proactively detects failures, rapidly diagnoses their root cause, and enables quick recovery. This chapter focuses on Application Insights' powerful capabilities for identifying, analyzing, and troubleshooting these critical issues using failures, exceptions, and the deep insights provided by the snapshot debugger. 7.1 The inevitability of failure. Why monitoring matters. In an ideal world, software would never fail. In the real world, failure means different things in different contexts. A user might experience a failure if an operation takes too long, even if no explicit error occurs. For developers and operations teams, a failure is often tied to an error state. An HTTP 500 internal server error, an unhandled exception crashing a process, or a dependency call timing out. Each failure, regardless of its type, impacts user experience, potentially leading to abandoned sessions, lost revenue, or reputational damage. The goal of monitoring in this context is threefold. Detection. Identify that a failure has occurred as quickly as possible. Diagnosis. Understand what happened, why it happened, and where in the system it originated. Remediation. Provide enough information to fix the underlying problem efficiently. Application Insights is purpose-built to empower you in these crucial steps, transforming scattered error messages into actionable, correlated insights. 7.2 Understanding failures in Application Insights. Application Insights categorizes two primary types of failures automatically collected from your application. Failed requests. These represent incoming HTTP requests to your web application that returned an error status code, e.g., 400s like bad request, 500s like internal server error, or any other status code that indicates a problem. Application Insights automatically flags requests with response codes 400 bad request or higher as failures by default, though this can be customized. Analyzing failed requests helps you understand the overall health of your web application from a functional perspective. A sudden increase in failed requests indicates a problem with your public-facing endpoints. Dependencies failed. As discussed in the previous chapter, dependencies are your application's outgoing calls to other services, databases, APIs, message queues. When these calls fail, e.g., a database connection error, an external API returning a 500 or a timeout, Application Insights flags them as failed dependencies. These are critical for understanding if your application's problems stem from its own code or from issues with the external services it relies upon. Both types of failures are visible in the Failures blade of your Application Insights resource within the Azure portal. This blade provides a high-level overview, showing trends of failed requests and dependencies over time, and grouping similar failures to help you identify the most impactful issues. 7.3 Exception Tracking. Catching the uncaught. While failed requests and dependencies point to high-level problems, exceptions provide the granular, code-level details about errors occurring within your application. Purpose. To capture detailed information whenever an abnormal event or error condition prevents your application from executing code as expected. Automatic collection. Application Insights SDKs are designed to automatically capture most unhandled exceptions that occur within your application's process. For example, if a net web application throws an uncaught exception, the SDK will typically intercept and send its details to Application Insights. Manual tracking, conceptual. Developers can also explicitly track exceptions using methods like trackException. This is useful for handled exceptions. When you catch an exception but still want to record its occurrence for analysis, even if it doesn't cause a full request failure. Specific error conditions. To flag custom error scenarios that might not throw formal exceptions but are still critical to monitor. Though for these, custom events or metrics might also be suitable. Key information captured. When an exception is collected, Application Insights records invaluable data for debugging. Exception type. The specific class of the exception, e.g., system null reference exception, system.net/http request exception. Exception message, a human-readable description of the error. Stack trace, the most critical piece of information. This is a list of all the method calls that were active at the moment the exception occurred, showing the exact line of code and file where the problem originated. This is your direct path to finding the bug in your source code. Properties. Contextual information like the user involved, the request ID, custom properties you might have added. The failures blade intelligently groups similar exceptions together based on their type, message, and stack trace, allowing you to see which errors are most prevalent. You can then drill down into a specific group to view individual instances of that exception, complete with their full stack trace and associated request details. Use case. Imagine users report that something goes wrong when I try to save my profile. By looking at the exceptions in Application Insights, you might see a recurring database write error with a stack trace pointing to a specific data access method. This immediately tells your development team where to investigate, saving hours of debugging time. 7.4 Snapshot Debugger, peeking into production faults. For the truly elusive, hard-to-reproduce bugs, seeing just the exception and its stack trace might not be enough. You might need to know the values of variables at the exact moment the exception occurred. This is where the Snapshot Debugger shines. Purpose: to automatically collect debug snapshots from your live production application when an exception occurs, allowing you to debug a production issue postmortem without directly attaching a debugger and impacting live users. How it works: conceptual. The Snapshot Debugger is typically enabled for Net and Net Core applications running on Azure services like App Service. When an application throws an exception that meets a predefined threshold, e.g., occurs more than a certain number of times, the Snapshot Debugger triggers. It captures a snapshot of the running process, including the full call stack and the values of local variables and parameters at the time of the exception. This snapshot is lightweight and has minimal impact on your live application. Once captured, it's sent to Application Insights and linked to the exception telemetry. Value: it's like having a debugger attached to your production application only when an error happens, giving you granular insights into the application's state without disrupting service. This is incredibly powerful for intermittent bugs, issues that are difficult to reproduce in development or testing environments; data-dependent bugs, errors that only occur with specific user input or particular database states; concurrency issues, race conditions that are nearly impossible to catch in a local debugger. When viewing an exception in Application Insights that has a snapshot associated with it, you'll see a button to open Debug Snapshot. Clicking this takes you to a special portal experience that resembles a debugging session, allowing you to inspect variable values across the call stack at the moment the error happened. Use case: a customer reports an order processing error, but your development team can't replicate it. Application Insights shows an invalid order state exception. With Snapshot Debugger, you open the snapshot and discover that a specific variable storing the order's status had an unexpected value, null instead of pending, which led to the exception, even though your code was designed to handle valid states. This crucial piece of information directly leads to the fix. 7.5 Failure Analysis and Diagnosis Workflow. When a failure or exception is detected, Application Insights streamlines the diagnostic workflow. Overview in Failures Blade. Start here to see the total count of failed requests and exceptions trending over time. Identify any recent spikes or anomalies. Root Cause Analysis, Top Failures. The Failures Blade automatically groups similar types of failures and exceptions. Prioritize the groups with the highest count or greatest impact. Drill down into a failure type. Click on a specific failed request operation or an exception type. This opens a more detailed view showing the trends over time for that specific failure, along with sample instances. Investigate a sample. Select an individual instance of a failed request or exception. This takes you to the end-to-end transaction details view. This is a powerful, correlated timeline showing all telemetry associated with that single operation. The incoming request itself, any dependency calls made during that request, any exceptions that occurred within that request, custom events or traces logged during that flow. This comprehensive view allows you to see the exact sequence of events, identifying if a slow dependency caused the failure or if an exception led to a failed request. Utilize stack traces and snapshots. For exceptions, immediately examine the stack trace to pinpoint the code line. If a snapshot is available, use it to inspect variable values for deeper debugging. Correlate with deployment and logs. Check if the failures coincide with a recent deployment. Use Kusto Query Language, KQL, in the logs blade to query additional context around the failure, e.g., surrounding log messages, user activity just before the failure. By leveraging these integrated features, Application Insights transforms the often frustrating process of bug hunting into a streamlined, data-driven investigation. Key takeaways: failures and exceptions are inevitable, but their impact can be minimized with the right tools. Application Insights provides robust capabilities to detect failed requests and dependencies, meticulously track exceptions with detailed stack traces, and, for net applications, even capture production snapshots for deep post-mortem debugging. By understanding and utilizing the integrated failure analysis workflow, you can rapidly pinpoint the root cause of issues, reduce mean time to resolution, and significantly improve the reliability of your applications. 8. Context and clarity, custom events, metrics, and user flows. Up to this point, we've focused heavily on the telemetry data that Application Insights automatically collects: requests, dependencies, exceptions, and system performance. This foundational data is invaluable for understanding the technical health and performance of your application. However, to truly elevate your observability, you need to go beyond the what's broken and start answering, how are users interacting? And, is my business logic performing as expected? This is where custom telemetry comes into play, transforming Application Insights from an APM tool into a powerful platform for understanding user behavior and business metrics. 8.1. The power of custom telemetry. Beyond the built-in. While Application Insights' automatic collection is excellent, every application has unique functionality, business processes, and user interactions that standard telemetry simply can't capture. For example, knowing that an HTTP request to checkout complete succeeded doesn't tell you how many items were in the customer's cart, the total value of the order, which payment gateway was used, whether the payment specifically timed out or failed for a business reason, not a technical one. This is where custom telemetry becomes indispensable. It allows you to gain deeper business insights, track specific user actions, feature usage, and business outcomes that are critical to your organization's goals. Segment your data. Add context that allows you to analyze performance or errors for specific user groups, product lines, or configurations. Monitor unique application logic. Track the internal workings of complex algorithms or background processes that don't manifest as web requests or dependencies. Application Insights provides two primary ways to send custom telemetry: custom events and custom metrics. 8.2. Custom events, tracking user actions and business processes. Custom events are discrete, time-stamped records of specific actions or significant occurrences within your application that you define. They are highly flexible and serve as the backbone for understanding user behavior and business logic. Purpose: to record moments that define user journeys or key business processes. Think of them as custom log entries for specific interactions you care about. When to use: user interaction. When a user clicks a button, submits a form, plays a video, or logs a specific action, e.g., add to cart, download report, search executed. Business process milestones. When a critical step in a business workflow is reached, e.g., order placed, customer registered, email sent. Internal application state changes. When something significant happens internally that isn't a performance metric or an error, e.g., cache refreshed, batch job started. Key value properties. The true power of custom events lies in their ability to carry contextual properties, key value pairs, and measurements, numerical values. Properties: these are non-numerical pieces of information that provide context to the event. For example, for an order-placed event, properties might include product-id, customer-id, shipping method, discount code applied. Measurements: these are numerical values associated with the event, allowing for aggregation. For an order-placed event, measurements could be order total, number of items, shipping cost. Conceptual example: instead of just knowing a successful payment request occurred, you might send a custom event. A payment processed event occurred with properties: customer-id, 123, payment gateway, Stripe, transaction status. Approved, and measurements: order total, 99.99, processing time 150. This single event captures rich business context that is invaluable for analysis, such as how many payment processed events occur daily? What's the average order total when payment gateway is Stripe? How many payment processed events have transaction status, declined, and what are their order totals? 8.3 Custom metrics, quantifying anything you want. Custom metrics are numerical values that you track over time. Unlike events, which are discrete occurrences, metrics are designed for aggregation and charting to show trends and patterns. Purpose: to track quantities, counts, or rates that change continuously and are meaningful for trending and alerting. When to use: internal counters. Number of items in a queue, count of active users in a specific feature, number of unprocessed messages. Resource utilization, non-standard. Custom cache hit rates, number of open database connections from your application pool. Business key performance indicators, KPIs. Daily active users, average session duration, conversion rates, though funnels can also achieve this. Performance beyond standard. Duration of a complex internal calculation, time spent rendering a specific UI component. Difference from custom events. Events are individual occurrences. You count the number of times an event happened. Metrics are numerical values that can be averaged, summed, or counted over time. You chart the value of a metric. While an event can contain a measurement, a custom metric is itself a numerical value designed for trending. Typically, you would choose one or the other based on whether you need detailed per-occurrence data, event, or just the aggregate trend, metric. Conceptual example: you might send a custom metric. My queue length metric currently has a value of 50. Or, my cache hit ratio metric has a value of 0.95. Over time, Application Insights collects these values, and you can then chart queue length to see if it's growing or shrinking, or monitor cache hit ratio to ensure your caching strategy is effective. 8.4 Understanding user flows, the customer journey. With custom events and automatically collected page views, you can reconstruct the paths users take through your application. Application Insights provides a powerful visualization tool called user flows, sometimes referred to as funnels or usage flows, in the Azure portal to help you understand common navigation patterns. Purpose: to visually explore the typical sequence of events and page views that users perform. It answers questions like, what do users typically do after visiting the product page? Or, where do users drop off during the checkout process? How it works conceptual. You start by selecting an initial page view or a custom event, e.g., home page loaded or added item to cart. The user flows report then generates a tree-like diagram showing the next most common steps taken by users, and the steps after that, along with the percentage of users who followed each path. Insights gained. Common paths. Identify the most frequently chosen paths by your users. Drop-off points. Spot stages where users abandon a process, e.g., a high percentage of users dropping off after entering shipping information. Unexpected behavior. Discover user behavior patterns that you didn't anticipate. Feature usage. Understand how users navigate to and from specific features and which features are most heavily used. Use case. A user flow starting from product page viewed might reveal that a significant number of users navigate to view cart, but then disproportionately drop off compared to those who continue to check out. This immediately highlights a potential issue with the cart page and directs your attention to it for optimization. 8.5 Segmentation and funnels. Analyzing user behavior. Building on custom events and page views, Application Insights also offers tools for more structured user behavior analysis. Segmentation. This involves breaking down your data by specific characteristics to understand how different groups of users behave. How it works. You can filter any telemetry data, requests, events, page views, by dimensions like user country, browser type, operating system, or custom properties you've added, e.g., user tier. Premium A/B test group. B. Insights. Is a payment method failing more often for users in a specific region? Are users on mobile devices unable to complete a particular form? Segmentation answers these questions, allowing for targeted improvements. Funnels. Funnels are a sequence of steps, page views, or custom events that you expect users to follow to complete a specific goal, e.g., registration, purchase, download. How it works: you define the steps in the funnel, e.g., viewed product page, added to cart, proceeded to checkout, payment completed. Application Insights then calculates the conversion rate between each step and for the entire funnel. Insights, conversion rates, how effectively users progress through a process. Bottleneck identification, pinpoint exactly where users are dropping off or abandoning the process. This highlights areas in your application's design or functionality that need improvement. Use case, a new registration process might be designed with 5 steps. By defining a funnel, you can see if 80% convert from step 1 to 2, but only 20% convert from step 3 to 4. This immediately tells you that step 3 is the primary barrier to successful user registration and requires investigation. Key takeaways. Custom telemetry fundamentally shifts application insights from a purely technical monitoring solution to a powerful business intelligence and user analytics platform. By thoughtfully instrumenting your application with custom events for specific actions and custom metrics for numerical trends, you gain unparalleled insights into user behavior and the performance of your unique business logic. Tools like user flows, segmentation, and funnels then empower you to visualize customer journeys, identify drop-off points, and make data-driven decisions that directly impact your product's success and user satisfaction. This is where observability truly extends its value beyond just technical operations. 9. Powerful analytics. Kusto Query Language, KQL, for deeper understanding. Throughout the previous chapters, we've explored the diverse types of telemetry collected by Application Insights and how pre-built visualizations in the Azure portal give you a snapshot of your application's health. However, to truly unlock the full potential of your telemetry data, to ask complex questions, identify subtle patterns, and custom tailor your insights, you need to speak its language. That language is Kusto Query Language, KQL. 9.1. The need for powerful querying. Think about the sheer volume of data your application generates. Thousands of requests per minute, millions of dependency calls per hour, and countless exceptions and custom events. Simply staring at raw log files or clicking through predefined dashboards isn't enough to make sense of this deluge. You need a powerful and flexible tool to filter out noise. Focus only on the data relevant to your current investigation. Aggregate data. Summarize vast amounts of raw data into meaningful totals, averages, or counts. Correlate across data types. Link a slow request to a specific exception, or connect a user action to a performance bottleneck. Identify trends and anomalies. Spot patterns over time or deviations from the norm. Create custom reports. Generate precisely the charts and tables you need for specific use cases or stakeholders. This is precisely what KQL, the query language used by Azure Monitor's log analytics, provides. It's designed for efficient querying of large volumes of structured and semi-structured data, making it the perfect analytical engine for application insights telemetry. 9.2 Kusto Query Language, KQL Fundamentals. KQL is a read-only query language developed by Microsoft for exploring your data and discovering patterns. If you've ever worked with SQL, you'll find some conceptual similarities, but KQL is specifically optimized for log data, featuring a pipeline-based syntax that is intuitive and highly readable. Schema and tables. As discussed in Chapter 3, your application insights telemetry is stored in a log analytics workspace and organized into specific tables. Each table represents a primary telemetry type, e.g., requests, dependencies, exceptions, traces, custom events. Each table has a defined schema of columns. For example, the request table contains columns like timestamp, name, duration, result code, success, client IP, and user ID. Basic structure. The pipeline operator. The fundamental principle of KQL is to start with a table, and then refine the results by passing them through a series of operators, chained together using the pipe symbol. Each operator takes the tabular output of the previous one as its input and produces a new, transformed table as its output. Think of it as an assembly line. Source table operator 1, operator 2, operator 3. Key KQL operators conceptual explanation. Where filter, the the most common operator used to filter rows based on specified conditions. You use comparison operators, e.g., equals equals, equals, equals equals, string operators, e.g., contains, starts with, has, and logical operators, and, or not. Conceptual goal, show me only the requests that failed. Project select columns. Used to select specific columns from the input table, rename them, or transform them to create new columns. It helps you focus on only the data you need. Conceptual goal, from those failed requests, I only want to see the timestamp, the URL, and the result code. Extend add columns. Used to compute new columns based on existing ones. This is powerful for deriving new metrics or properties from your raw data. Conceptual goal, calculate the duration of a request in seconds instead of milliseconds. Summarize aggregate, the most powerful operator for aggregation. It groups rows by one or more columns and then calculates aggregate functions, e.g. count, sum, avg, min, max, decount, for distinct count over the grouped data. Conceptual goal, count the number of requests per hour, grouped by the URL path. Conceptual goal, calculate the average duration for each type of dependency. Top limit, limit results. Used to return only the first n rows after sorting, or simply n arbitrary rows. Conceptual goal, show me the top 10 slowest requests. Order by, sort results. Used to sort the rows in ascending ask or descending desk order based on one or more columns. Conceptual goal, sort the list of exceptions by the most recent ones first. Union, combine tables. Used to combine rows from multiple tables, provided they have compatible schemas. Conceptual goal, show me all requests and all dependency calls together based on their timestamp. Join merge tables. Used to combine data from two tables based on matching values in common columns, much like SQL joins. Conceptual goal, find all requests that explicitly called a specific slow external API. Joining requests and dependencies tables using their shared operationid. 9.3 Practical KQL scenarios describe the goal, not the query. KQL empowers you to ask highly specific questions of your application insights data. Here are some common scenarios and the kind of KQL query you might construct, conceptually. Finding all failed requests in the last 24 hours. Goal, filter the requests table for a specific time range where the success status is false. Calculating average response time per country for successful requests. Goal, filter requests for successful ones, then summarize by taking the AVG of duration and count of requests, grouped by client, country, or region. Identifying users experiencing the most exceptions. Goal, starting with the exceptions table, summarize by counting exceptions, grouped by distinct userid, and then order by the count in descending order. Correlating specific custom events with performance issues. Goal, join custom events, e.g., an event product search with requests telemetry where they share the same operationid, then filter for slow requests or specific dependency failures occurring within that operation. Analyzing dependency failures to a specific external service. Goal, filter the dependencies table for success is false and type is HTTP and target contains externalapiurl.com, then summarize by target to see the most problematic endpoints. Monitoring daily unique users. Goal, from the page views or requests table, summarize by the decount, distinct count of userid over a one-day time interval for timestamp. Visualizing CPU utilization alongside request count. Goal, query the performance counters table for counter name processor \\% processor time and the requests table for counts, then use the makeseries operator to combine them into a time series for charting. These are just a few examples, but the flexibility of KQL means you can combine operators in countless ways to extract virtually any insight you need from your telemetry. Many application insights blades in the Azure portal, like the performance or failures blades, even show you the underlying KQL query they use, serving as excellent learning examples. 9.4 Time series analysis and visualization. KQL is particularly strong in time series analysis. When you query data, you'll almost always include a time range. KQL allows you to specify time windows, use the ago, function to define relative time ranges, e.g., where timestamp ago 1h for the last hour. Summarize by time grain, aggregate data into specific time bins, e.g., summarize count by bin timestamp 5m to count events every 5 minutes. This is crucial for creating smooth, readable charts. Visualize results. The Log Analytics query editor in the Azure portal allows you to easily switch between a raw table view of your query results and various chart types: line, bar, pie, scatter, etc. This makes it simple to visualize trends, patterns, and anomalies identified by your queries. The ability to write a powerful query and immediately transform its output into a clear, interactive chart is one of the most powerful aspects of using KQL with Application Insights. 9.5 KQL for alerting brief mention. Beyond ad hoc analysis, KQL queries form the basis for advanced alerting in Application Insights. You can take any KQL query that returns a numerical result and use it to define an alert rule. For example, if your query returns the number of failed payments over a 5-minute window, you can configure an alert to fire if that number exceeds a certain threshold. This enables highly specific and intelligent alerting tailored to your application's unique needs. We will cover this in more detail in the next chapter. Key takeaways. Kusto Query Language, KQL, is the analytical powerhouse behind Application Insights. It provides a flexible, powerful, and intuitive way to query, filter, aggregate, and transform your voluminous telemetry data. By mastering the pipeline approach and key operators like where, project, summarize, and join, you transform raw information into precise, actionable insights. KQL empowers you to move beyond predefined dashboards and ask virtually any question of your data, unlocking the true potential of Application Insights for deep understanding and proactive problem-solving. 10. Integration and automation. Alerts, dashboards, and DevOps workflows. We've covered how Application Insights collects rich telemetry and how Kusto Query Language, KQL, empowers you to analyze it deeply. But simply having data and the ability to query it isn't enough for effective monitoring and operations. You need to be proactively warned when issues arise, have visually compelling summaries of your application's health, and integrate these insights directly into your development and operational processes. This chapter focuses on how Application Insights integrates with the broader Azure ecosystem to enable powerful alerts, informative dashboards, and streamlined DevOps workflows. 10.1. The importance of automation and observability. In modern cloud environments, manual monitoring is simply unsustainable. Applications generate too much data, and incidents can occur at any time. Effective observability relies heavily on automation to proactive detection, identify problems automatically, often before users even notice them. Rapid response. Alert the right people or systems immediately so they can investigate and resolve issues quickly. Reduced alert fatigue. Ensure that alerts are intelligent and actionable, minimizing unnecessary noise. Operational efficiency. Integrate monitoring feedback into development and deployment pipelines, making systems self-healing or preventing problematic changes from reaching production. Information dissemination. Present key health indicators in easily consumable formats for different stakeholders. Application Insights, as a core component of Azure Monitor, is designed with these principles in mind, offering robust capabilities for automation and integration. 10.2. Setting up smart alerts with Azure Monitor. Azure Monitor alerts are your application's alarm system. They proactively notify you or trigger automated actions when specific conditions are met based on your telemetry data. This means you can shift from a reactive, waiting for user complaints, model to a proactive, get notified when something is wrong approach. Application Insights telemetry can power two primary types of alerts: metric alerts, basis. These alerts are based on numerical metrics collected by Application Insights, e.g., server response time, failed requests, CPU usage, custom metrics. Configuration. You define a metric, a time aggregation, e.g., average over past 5 minutes, a threshold, and the operator, e.g., greater than, less than. Example. Alert me if the average server response time is greater than 1 second for 5 minutes. or alert me if the number of failed requests exceeds 10 per minute. Log query alerts. Basis. These are more powerful, allowing you to define alerts based on the results of a Kusto Query Language, KQL query. Any KQL query that returns a numerical result can be used. Flexibility. This allows for highly specific and nuanced alerting. You can alert on the count of a specific exception type, the number of times a particular custom event occurs, e.g., payment failed events, the percentage of users in a certain browser experiencing an error, a complex calculated metric from combining multiple telemetry types. Example: alert me if the KQL query counting login failed events with result code invalid credentials returns more than 50 in the last 15 minutes. Key alert configuration concepts. Thresholds, the value that when crossed triggers the alert. Period and frequency, how often the alert rule is evaluated and the timeframe over which the data is aggregated. Severity levels. Alerts are categorized, severity 0 to 4, critical to verbose, to indicate their urgency, influencing how they are handled. Dynamic thresholds, brief mention. For some metrics, Azure Monitor can use machine learning to automatically learn normal patterns and alert when there's an unusual deviation, reducing the need for manual threshold tuning. Action groups. Once an alert condition is met, an action group defines what happens next. Action groups are reusable collections of notification preferences and automated actions. They are central to alert configuration and can include notifications, email, SMS, push notifications to the Azure mobile app, voice calls, automated actions, webhook, call a custom HTTP endpoint, e.g., to integrate with PagerDuty, Slack, Microsoft Teams, or custom remediation systems. Azure Function Logic App, trigger an Azure function or logic app to perform arbitrary custom automation, e.g., open a ticket in an ITSM system, restart a service, post to a communication channel. ITSM tools. Create work items directly in supported IT service management solutions like ServiceNow. By setting up robust alerts with carefully configured action groups, you ensure that critical issues are immediately brought to the attention of the right individuals or automated systems, facilitating rapid response and problem resolution. 10.3. Crafting informative dashboards. While alerts tell you when something is wrong, dashboards provide a continuous, high-level overview of your application's health and key performance indicators. They are visual summaries, making complex data digestible at a glance for various audiences. Azure dashboards are customizable panes within the Azure portal where you can pin various tiles. Application Insights provides many types of data that can be pinned to dashboards. Metrics charts. Pre-built charts from Application Insights showing server response time, failed requests, page views, CPU, etc. Log query results. Output of KQL queries, presented as tables or various types of charts, line, bar, pie, scatter. This is incredibly powerful as it allows you to visualize any insight you can extract with KQL. Application map. A live, interactive view of your application architecture. Web test results, availability statistics for your URL ping or multi-step web tests. Workbooks. Interactive reports that combine text, analytics queries, metrics, and parameters into rich monitoring experiences, more advanced, but can be pinned. Best practices for dashboards. Target audience. Design dashboards for specific roles. An operations team might need a system health dashboard with CPU, memory, and error rates. A product management team might want a business performance dashboard with user counts, conversion rates, and feature usage from custom events. Focus on KPIs. Don't overload dashboards with too much information. Focus on the most important key performance indicators, KPIs, that represent the health and business value of your application. Simplicity and clarity. Use clear titles, labels, and appropriate chart types. Ensure the data is easy to interpret quickly. Actionable insights. Dashboards should help users understand if something needs attention. If a metric is trending poorly, the dashboard should clearly indicate it. Regular review. Dashboards can become stale. Regularly review and update them to ensure they remain relevant and useful. Dashboards serve as a central source of truth for your application's status, fostering shared understanding and accountability across teams. 10.4 Integrating app insights into DevOps workflows. Observability shouldn't just be an afterthought. It should be woven into the fabric of your DevOps practices. Application Insights integrates deeply with continuous integration, continuous delivery, CI/CD pipelines, enabling automation that improves release quality and speeds up incident response. Automated instrumentation, CI/CD. Your build pipeline can automatically configure the connection string or instrumentation key for your application Insights SD case based on the target environment, dev, test, prod. This ensures that every deployment to a given environment automatically sends telemetry to the correct application Insights resource. Release gates quality gates. This is a highly impactful integration. Your deployment pipeline, e.g., Azure DevOps pipelines, GitHub Actions, can be configured to pause a release if certain application Insights metrics or log query results show anomalies in the newly deployed environment. Example: after deploying to a staging environment, wait 10 minutes and check if the average server response time is below a threshold. The failed requests rate is below a threshold. No new critical exceptions have appeared. If the gates fail, the deployment can be automatically rolled back or require manual intervention, preventing bad code from reaching production. Automated rollbacks. In more advanced scenarios, upon detection of critical performance degradation or error rates via application Insights alerts in production, an automated process could trigger a rollback to the previous stable version of the application. Pre-production environment monitoring. Use application Insights to thoroughly monitor your test and staging environments. This helps identify performance regressions or bugs before they impact production users. Performance testing tools can push load onto these environments, while application Insights monitors their behavior, ensuring new features don't introduce performance bottlenecks. By embedding application Insights into your CI/CD pipelines, you establish a continuous feedback loop, making your releases safer, faster, and more reliable. 10.5 Custom automation with Azure Functions and Logic Apps. Beyond predefined alerts and release gates, application Insights can be extended to perform complex custom automation using Azure Functions and Logic Apps. Reacting to alerts. When an application Insights alert fires, it can trigger an Azure Logic App or Azure function via a webhook action. Scenario 1. When a P1 alert for critical failed dependency occurs, an Azure function could automatically post a detailed message to your team's Slack Teams channel. Create a high-priority incident in your ITSM system, e.g., Jira, ServiceNow. Trigger an automated runbook to attempt a self-healing action, e.g., restart a dependent service, scale out an application instance if CPU is high. Scenario 2. If a custom metric for failed payments spikes, a Logic app could notify the business team, collect a diagnostic log from the affected service, and open a ticket. Periodic data analysis. Azure Functions or Logic apps can be scheduled to periodically query application Insights data using KQL, and then perform custom actions based on the results, e.g., generate a daily summary report, identify inactive users, or trigger data cleanup in external systems. This level of integration allows for highly flexible and powerful automation, turning application Insights data into actionable insights and proactive responses for virtually any operational scenario. Key takeaways. Application Insights is not just a data collection tool. It's a central component in your observability strategy that integrates deeply with the Azure ecosystem for automation and streamlined operations. By configuring smart alerts, metric-based and KQL-based, tied to flexible action groups, you ensure proactive notification and automated responses. Well-designed dashboards provide at-a-glance health summaries for different stakeholders. Finally, embedding application Insights into your DevOps workflows via release gates and automated actions ensures safer deployments, faster incident resolution, and ultimately, more reliable applications. 11. Advanced scenarios, distributed tracing, sampling, and pricing considerations. Having mastered the foundational aspects of application Insights, telemetry collection, real-time insights, availability, performance, and automation. It's time to delve into some more advanced topics. This chapter will explore sophisticated capabilities like distributed tracing for unraveling complex microservice interactions. Understand the crucial role of sampling in managing telemetry volume, and address the practical considerations of application insights pricing model. 11.1 Deeper into distributed tracing. In simple terms, a trace is a collection of events and data that together represent the full execution flow of a single request or operation through an application. In a monolithic application, this meant following a function call stack within a single process. However, in today's microservices architectures, a single user request might traverse multiple services, queues, databases, and even different cloud regions. Distributed tracing is the mechanism that stitches together all these disparate parts into a single, cohesive narrative. Definition: distributed tracing is the process of tracking a single request or operation as it flows across multiple services, processes, and network boundaries within a distributed system. It provides a complete end-to-end view of how a request is handled. Correlation IDS. The magic behind distributed tracing in application insights lies in correlation IDS. When an incoming request arrives or an outgoing call is made, Application Insights SDKs automatically inject unique identifiers, operation ID, parent ID, into the HTTP headers or other context propagation mechanisms. When the request then calls another service, these IDs are propagated. Subsequent telemetry generated by the downstream service, e.g., its own requests, dependencies, or exceptions, are tagged with the same operation ID, ensuring that all related telemetry across different services can be linked together. Role of Open Telemetry, brief. The industry is moving towards vendor-neutral specification for instrumenting applications for observability. Open Telemetry is an open-source project that provides a standardized set of APIs, SDKs, and tools for collecting telemetry, metrics, logs, and traces. Application Insights is increasingly compatible with Open Telemetry, allowing greater flexibility in how you instrument your applications while still leveraging application insights for backend storage and analysis. Application Maps Role. As seen in Chapter 4, the application map graphically represents the distributed calls and dependencies. It's the visual manifestation of your distributed traces. When you click on a component or connection in the application map, you can often drill down to view the underlying end-to-end transactions. Transactions search/end-to-end transaction details. Within Application Insights, you can search for individual transactions by user, operation name, or even specific properties. Once found, the end-to-end transaction details view provides a detailed timeline or waterfall chart of that specific request. It shows all the individual requests, dependencies, and exceptions that occurred during that operation, across all involved services, along with their timings. This view allows you to identify which service or dependency in the chain contributed most to the overall latency, pinpoint where an error originated in a multi-service interaction, understand the exact flow of data through your system. Use case: a customer complains that my order is stuck. In a microservice architecture, this could involve an order service, a payment service, an inventory service, and a shipping service. By looking at a distributed trace for that specific order ID in Application Insights, you might discover that the payment service successfully processed the payment, but the call to the inventory service hung for 30 seconds before timing out, leading to the order being stuck, even though your order service thought it sent the command. This level of detail is invaluable for diagnosing complex issues in distributed systems. 11.2 Understanding telemetry sampling. Modern applications can generate an enormous volume of telemetry data. For a high-traffic application, sending every single request, dependency call, and log message could quickly become overwhelming both in terms of data processing and cost. Telemetry sampling is Application Insights' intelligent solution to this challenge. The problem: high-volume telemetry can be costly and difficult to manage. Sampling as a solution. Sampling is the process of reducing the volume of collected telemetry while still preserving a statistically representative view of your application's behavior. Instead of sending all telemetry, it sends only a subset. Key principle: the goal of sampling is not to lose critical data. Application Insights ensures that, for any given transaction, all related telemetry items, requests, dependencies, exceptions, custom events, are either collected together or dropped together. This maintains the integrity of distributed traces and ensures that when an error occurs, you still get all the context needed to diagnose it. Types of sampling: adaptive sampling, default, and recommended. How it works: this is the default sampling type for most Application Insights SDKs. It dynamically adjusts the volume of collected telemetry based on the current volume, attempting to keep the data volume below a defined daily cap. When traffic is low, it collects almost everything. As traffic increases, it intelligently samples more aggressively, but critically, it tries to always keep all telemetry related to a single distributed trace, i.e., all items with the same operation ID. Benefits: requires minimal configuration, effectively manages data volume, and prioritizes complete traces for diagnostic purposes. Impact on metrics: when sampling occurs, Application Insights automatically compensates for it when presenting aggregated metrics, like request counts or response times, in the portal or query results. It scales up the counts to provide accurate totals, even if only a sample was collected. So, if your app processed 100 requests and only 10 were sent, 10% sample, the portal will show 100, not 10. Fixed-rate sampling: how it works: you explicitly configure the SDK to collect a fixed percentage of all telemetry, regardless of the volume. For example, you might set it to 10%, meaning 10% of all telemetry will be sent. Use case: useful when you need a very consistent sample rate, perhaps for specific performance testing scenarios, or when adaptive sampling might not be ideal, e.g., if you have very spiky traffic and want to ensure a minimum sample rate at all times. Ingestion sampling: how it works. This type of sampling occurs after the telemetry has already been sent to the Application Insights service endpoint, but before it's stored. It's a last resort mechanism to prevent excessive data ingestion if client-side sampling is misconfigured or unable to keep up. Benefit: provides a safety net against accidental high ingestion. Consideration: it's generally better to perform sampling at the SDK level, adaptive or fixed rate, to avoid sending unnecessary data over the network and incurring associated costs. When to disable sampling: while sampling is almost always beneficial, there might be specific scenarios where you want to adjust or even temporarily disable it. Low traffic applications: for dev/test environments or internal tools with very low traffic, you might want 100% telemetry to ensure you don't miss anything. Debugging critical issues: temporarily disabling sampling for a short period during a critical incident can provide a complete picture of all activity at the expense of potentially higher cost. Specific analytics needs: if you require every single instance of a very rare event for auditing or specific analysis, you might need to filter out that telemetry from sampling. Understanding sampling is crucial for interpreting your data and managing your application insights costs effectively. 11.3. Managing data volume and retention. Beyond sampling, actively managing your data volume and retention is key to keeping costs in check without sacrificing valuable insights. Controlling ingestion: be mindful of what you send. While Application Insights is designed to handle high volumes, excessive logging of non-critical information, e.g., verbose debug messages in production, can inflate your data volume significantly. Filtering telemetry: Application Insights SDKs allow you to implement custom iTelemetry processor components, or similar mechanisms depending on the SDK, that can inspect and filter out specific telemetry items based on your custom logic before they are sent to Azure. For example, you might choose not to send health check requests or telemetry from specific internal IP ranges. Data retention: all Application Insights telemetry ultimately resides in a log analytics workspace. The workspace has its own data retention setting, which determines how long your data is stored. Default, typically 31 days free for log analytics. Customization. You can increase the retention period, e.g., 90 days, a year, or more, but this incurs additional cost. You should balance your need for historical data with your budget. For example, you might keep detailed operational logs for 30 to 90 days, but aggregate some key metrics for longer-term trending. 11.4 Pricing Model and Cost Optimization. Application Insights pricing is straightforward and primarily based on the volume of data ingested, measured in GB per month, and the data retention period. There are also small charges for web tests and continuous export, but these are typically minor compared to data ingestion. Factors influencing cost. Data ingestion volume, the most significant factor. The more telemetry data your application sends to Application Insights, the higher the cost. This includes all telemetry types: requests, dependencies, exceptions, traces, custom events, custom metrics, and performance counters. Data retention. Storing data for longer than the default retention period incurs additional charges per GB per month. Web tests. A small charge per test per month, based on the number of locations and frequency. Strategies for cost optimization. Effective sampling. As discussed, adaptive sampling significantly helps manage data volume. Ensure it's enabled and configured appropriately. Intelligent filtering. Use custom telemetry processors or equivalent SDK features to prevent specific, non-essential telemetry, e.g., health checks, verbose debug logs, or telemetry from internal load balancers, from ever being sent. Optimize custom telemetry. Be judicious with custom events and metrics. Only send the data that you genuinely need for analysis or alerting. Avoid sending large JSON objects as properties if only a few key value pairs are relevant. Monitor ingestion volume. Use the usage and estimated costs blade in your Application Insights resource to monitor your daily data ingestion. This helps you identify spikes or unexpected growth patterns and understand the current cost. Review retention policies. Periodically assess if you truly need to store all data for the configured retention period. Reducing retention, even by a few days, can significantly lower costs for high-volume applications. Leverage metrics for trends. If you need long-term trends for certain values, e.g., average users per day, but don't need the raw, individual events, consider sending these as custom metrics instead of custom events, or aggregating them into a separate log metric to be stored for longer periods. Understanding these factors and applying optimization strategies ensures that you get the most value out of Application Insights without incurring unnecessary expenditure. It's about being smart with your data. Key takeaways. Beyond the basics, Application Insights offers advanced capabilities that are essential for large-scale, complex applications. Distributed tracing provides unparalleled visibility into how requests flow across microservices, enabling rapid diagnosis of cross-service issues. Telemetry sampling is a vital mechanism for managing the vast volumes of data generated by modern applications, keeping costs in check while preserving diagnostic integrity. Finally, a clear understanding of the pricing model and proactive cost optimization strategies ensures that your observability efforts are both powerful and economically sustainable. 12. Mastering your monitor. Best practices, troubleshooting, and the future of observability. You have journeyed from the foundational concepts of observability to the intricate details of Application Insights capabilities. From collecting basic telemetry and creating real-time dashboards to performing deep analysis with Kusto Query Language, automating alerts, and understanding advanced features like distributed tracing and sampling. This final chapter consolidates that knowledge with practical best practices, offers guidance on common troubleshooting scenarios, and peers into the exciting future of observability, urging you to embrace an observability mindset for continuous improvement. 12.1 Key Best Practices for Application Insights Excellence. Successfully implementing and leveraging Application Insights is as much about process and philosophy as it is about technology. Adopting these best practices will help you maximize your return on investment and build more resilient applications. Instrument early and often. Don't wait until production to integrate application insights. Implement it in development and test environments. This allows you to collect baseline data, validate your instrumentation, and catch performance issues and bugs much earlier when they are cheaper and easier to fix. Balance automatic and custom telemetry. Leverage application insights' robust automatic collection for requests, dependencies, and exceptions. This provides a great foundation. However, don't shy away from adding custom events and metrics for unique business logic, specific user interactions, and internal process monitoring. This custom data is where you derive deeper, application-specific insights. Use consistent naming conventions. Establish clear and consistent naming conventions for your custom events, metrics, properties, and even resource names, e.g., order placed versus order placed. This makes your data easier to search, query, and understand for everyone on the team, preventing confusion and ensuring data integrity over time. Leverage properties for context. Every piece of telemetry should tell a story. Enrich your custom events, metrics, and even automatically collected data with relevant properties. Examples include userid, sessionid, deploymentid, environment, feature flag state, source location. The more context you attach, the easier it is to filter, segment, and diagnose issues. Educate your team. Application Insights is most effective when your entire team understands how to use and interpret its data. Train developers on how to instrument their code. Show operations teams how to use dashboards and alerts, and empower product managers to find insights into user behavior. Foster a culture where data-driven debugging and decision-making is the norm. Regularly review dashboards and alerts. Dashboards can become stale, and alerts can lead to alert fatigue if not managed. Periodically review your dashboards to ensure they are still relevant and actionable. Similarly, review alert rules to fine-tune thresholds, remove false positives, and ensure notifications go to the right people. Treat your alerts as living documents. Monitor your monitor. Use Application Insights to monitor your application insights usage and performance. Track data ingestion volume, query performance, and the health of your web tests. This ensures your monitoring solution itself is healthy and cost-effective. Continuous improvement. Telemetry needs evolve with your application. Regularly revisit your instrumentation strategy. Are you still collecting the most valuable data? Are there new features that need monitoring? Are there old integrations that can be removed? 12.2 Common troubleshooting scenarios. Even with the best planning, you might encounter issues with Application Insights itself. Here are some common problems and their typical solutions. My application is running, but no data is appearing in Application Insights. Check connections string instrumentation key. Verify that your application is configured with the correct connection string or instrumentation key for the Application Insights resource. This is often an environment variable or configuration file setting. SDK initialization. Ensure the Application Insights SDK is correctly initialized in your application's startup code. Network firewall rules. Confirm that your application, or its host, has outbound connectivity to Application Insights endpoints. Azure services usually handle this automatically, but on-premises or custom network configurations might block traffic. Application is running. Is the application actually running and processing requests? No traffic means no telemetry. Azure Region Service Health. Check the Azure Service Health dashboard for any regional outages affecting Application Insights. Some data is appearing, but my custom telemetry is missing incomplete. Verify track calls. Ensure that your track event, track metric, etc. calls are actually being executed in your code. Set breakpoints in development. SDK versions. Ensure you are using up-to-date SDK versions. Sampling. Remember that sampling might reduce the volume of custom telemetry. If you're looking for a specific individual item and sampling is aggressive, you might not see it, though aggregate counts should still be accurate. Filters processors. Check if you have any custom telemetry processors or filters configured in your SDK that might be intentionally dropping certain telemetry. My metrics charts look wrong or are not updating correctly. Time range, the most common mistake. Always check the selected time range in the Azure portal. You might be looking at data from a week ago when you expect live data. Aggregation. Ensure the correct aggregation, e.g., average, sum, count, is applied to your metric or query. Sampling compensation. Remember that Application Insights automatically compensates for sampling in aggregated metrics. Trust the numbers in the portal. If you're comparing against raw counts from your application, account for the sample rate. Data latency. While live metrics is real-time, other portal blades and KQL queries have a small ingestion latency, typically a few minutes. Application Insights costs are too high. Usage and estimated costs. Regularly review the usage and estimated costs, blade in your Application Insights resource to understand daily ingestion volume. Sampling. Reevaluate your sampling strategy. If adaptive sampling is not capping volume effectively, consider a fixed-rate sample. Custom telemetry volume. Identify if a particular custom event or metric is sending an unnecessarily high volume of data. Are you sending every debug message as track trace in production? Retention. Check your data retention period in the log analytics workspace. Shortening it can reduce costs. Unnecessary data. Implement filtering to drop non-critical or redundant telemetry before it's sent. 12.3 Beyond Application Insights. The broader observability ecosystem. Application Insights is a powerful tool, but it's part of a larger ecosystem. While it excels at APM and application-level observability, a truly comprehensive observability strategy often involves Azure Monitor, the umbrella service that includes Application Insights, as well as solutions for infrastructure monitoring, VMS, containers, network monitoring, database monitoring, and more. Application Insights data lives within Azure Monitor's log analytics workspaces, allowing you to correlate application health with underlying infrastructure health. Azure Dashboards. Custom dashboards built from Application Insights data alongside other Azure Monitor data provide a single pane of glass for monitoring your entire Azure estate. Azure Alerts and Action Groups. Used by Application Insights, but also for other Azure services, providing unified alerting across your cloud environment. OpenTelemetry. As mentioned, the industry is increasingly embracing OpenTelemetry as a vendor-agnostic standard for collecting observability data. While Application Insights has its own SDKs, its increasing compatibility with OpenTelemetry means you can use standardized instrumentation and still send your data to Application Insights for analysis. This provides flexibility and portability for your instrumentation code. Other specialized tools. For deep network packet analysis, security information and event management, SIEM, or highly specialized performance profiling, you might integrate Application Insights with other tools in your IT environment. 12.4 The future of observability and Application Insights. Observability is a rapidly evolving field, and Application Insights continues to adapt and grow. Several trends point to its future direction. Increased AI/ML for anomaly detection. Application Insights already uses some machine learning, e.g., for dynamic thresholds. Expect more advanced AI-driven anomaly detection, root cause analysis, and predictive capabilities to further reduce alert noise and proactively identify issues. Closer integration and federation. Tighter integration with other Azure services, third-party analytics platforms, and perhaps even cross-cloud observability will become more seamless. The ability to federate data across different tools and platforms without heavy manual extraction will simplify complex environments. Full-stack observability. The trend towards unifying logs, metrics, and traces across the entire technology stack, from infrastructure and network to application code and user experience, will continue. Application Insights will play a key role in providing this application-centric view within a broader, full-stack context. More focus on business observability. While APM is technical, the ultimate goal is business impact. Expect more features that directly translate technical telemetry into actionable business insights, dashboards, and KPIs, making observability relevant to all stakeholders. Simpler onboarding and configuration. As applications become more complex, the tools to monitor them need to become simpler to use, with more intelligent auto-instrumentation and configuration. 12.5 Final Thoughts. Embracing an observability mindset. Beyond the features and functionalities, the most important takeaway from this book is the shift towards an observability mindset. It's not just about installing a tool. It's about integrating the ability to understand your system's internal state into every step of your development lifecycle. Design for observability. Think about what telemetry you'll need when designing features. Instrument with intent. Add custom telemetry that provides context and answers key business questions. Debug with data. Use Application Insights as your primary diagnostic tool when issues arise. Release with confidence. Use monitoring as a feedback loop in your CI/CD pipelines. Optimize continuously. Use the data to make informed decisions about performance, resource usage, and user experience. By embracing this mindset, you empower your teams to build, deploy, and operate applications that are not just functional, but truly resilient, performant, and delightful for your users. Azure Application Insights provides you with a powerful lens into your application's world, allowing you to see problems before they escalate, understand behavior at an unprecedented level, and continuously improve your software delivery. The journey of mastering your monitor is an ongoing one, but with the knowledge gained from these chapters, you are well equipped to navigate it successfully. Suggested further reading and resources. Microsoft Learn documentation for Azure Monitor and Application Insights. docs.microsoft.com/azure/azure-monitor/app/. Kusto Query Language, KQL documentation. docs.microsoft.com/azure/data-explorer/kusto/query/. Azure Architecture Center for guidance on designing observable cloud solutions. Azure blog posts and community forums. Stay up to date with new features and community best practices. Open Telemetry Project. Explore the leading open-source project for telemetry instrumentation. The application world is dynamic. Continuous learning and adaptation are key. Go forth and observe.